Alrighty guys, so we're going to be talking about the natural base E, and I'm going to go ahead and start a little bit about, about how we came to the natural base E. The natural base E, first and foremost, we get it from this person named Euler. You can kind of see how we now have the letter E as we know it today, because the guy who found it, in his name and in his honor, they took his first letter of his name and they made it the constant. Now, E in and of itself, we have to be very careful of not thinking of it as a variable. It is a constant. When we talk about E, we say E is approximately 2.71828, and it just keeps on going and going and going, okay? It goes on forever. It's very much like things we know as pi and other forms of constants that go on forever, because pi is like 3.14 and it just keeps on going, right? Now, how we get to this 2.718 is people and mathematicians were kind of looking at, compound interest, and they were asking themselves, if I were to go ahead and, take $1, say we have $1, and we were to pay 100% interest per year on it. Well, if I got 100% interest on $1, that means I'd have $2, right? Because I get 100% of what I put in. So now I have $2. Now, the idea though is they wanted to know what would happen if you were to apply that interest more frequently during the year. So say you were to apply this interest twice a year, okay? So what they ended up doing is they took this $1 and they said, alrighty, I'm going to apply the 100% twice. So that means there's two sets of 50%, right? Because you're doing the whole 100%, but you're doing it 50% once in the year and 50% again at the end of the year. So this means, and also keep in mind, if you want to have growth, you have to multiply it by a 1, and then the interest is after the 1. So the 50% is the 5 here, so it's the 1.5. And we did that across twice, right? We did it twice, right? Because we did a 50% and a 50%. So that would give you $2.25. Then they said, well, what if we compounded it quarterly? So then we said, all right, let me take that $1 and let me multiply it. Now, quarterly, remember, is 0.25, right? So we did 0.25. And since it's quarterly, that's across 4 times a year. And that gives you 2.4414, okay? And what they started to notice is they were saying to themselves, well, I'm actually developing an equation, because say I wanted to do something like compound monthly, like take that $1. It's essentially 1, right, plus, because this 1 right here is this 1 right here, okay? Now, the additional part would be the monthly. Now, monthly meaning how many months are in a year? 12, right? And we did talk about that in previous videos. So that would mean 12 times a year, but we want to make sure that it's out of a whole, right? So it's a 1/12, so we do it every month, so 1/12, so every month, and we do it across 12 months because there's 12 of them, right? And we would find out that we'd have this 2.613035, and it just keeps on going, okay? And that would be the dollar amount. Now, what they did is they then took this equation, 1 plus 1 over n, raised to the n, because they noticed that these values right here, the 12 and the 12 were the same, so they said n and n. And so this little section right here, okay, this whole little equation, oh, that's not a highlighter. This whole section right here became known as E, okay, this right here. So this is E. And we noticed that if we went ahead and did like very large numbers, because we wanted to see how many times we could compound it. And we noticed that if we compounded it at very large numbers, it started to reach a point to where it would stop growing. And in fact, and when I say stop growing, I mean that it will continue to gradually grow, but it won't exceed this particular asymptote. And it kind of just curved off. And if you want to uncover that more and kind of see where all that came from, definitely ask me and I will talk about this more in depth. I just know we have limited time for this video. But if you were to look at it graphically, graph-wise, it starts to do this. It starts to grow, and then it tailors off, and then the asymptote in which it cannot surpass, that is the value of E, and that is the 2.7 yada yada yada. So this is going to continuously try to grow closer and closer and closer to that value of E, but it just won't surpass it. Okay, so that hopefully gets you an idea. So E is a number, it's not a variable. Okay, so let's kind of look at the basic application of how some of these E's will interact with one another. So looking at E, we can see that if E's were to be multiplied together, so we have E times 3 times E to the 6, we actually treat it with the same rules as the variables that we've worked with in the past. We notice that E's, they're both the same base, so I could go ahead and say that that's E to the 9th, right? Because when you multiply, you add those together. Same can be said for when you have E to the 5th power divided by 4e to the 4th, 4e to the 4th power. So that's going to give you 4, right? Because 16 divided by 4 is 4. And then E, okay, you would have 5 minus 4 because when you're doing division, you subtract this time, right? So this would end up giving you 4e to the 1 power, okay? Now, you can also see other ways E is used by doing rational exponents and also the rules of exponents. Sticking with this, we have negative 4x raised to the 2 power. That 2 is going to find itself placed into each one of these values, right? Because that's one of the rules. It's going to go to this guy and to the 3. So I have 3 squared. And then I have E, and then I have negative 4x, and then times 2, okay? So what that's going to do is that's going to give me 3 squared is 9, E, and then negative 4 times 2, that's negative 8x. Now, remember, what do we do when the exponents are negative? Well, we move it down into the denominator, okay? So I'd have 9 on top because he doesn't have a negative exponent, but the E does, and so I have E to the 8x, okay? And that comes from our rules, okay? So hopefully that gives you some insight on just kind of how E is used and incorporated. Now, there is going to be another video that I've posted about how we incorporate and do the application of E. Let me know if you guys have any questions on that. I'm going to, in this video here, look at that applications video and then start the homework, and then you should be good to go. Thank you for tuning in, guys. Alrighty, bye.